working. So, in order to get the pivot positions of the wheels, we've written a script and we've coded it so that we select the wheels in a particular order. So it's going to go front left, front right, rear left, rear right. We run our script and it's going to create some locators, and the locators are going to be in the positions which we want our wheels to rotate from. Okay, so that's the script working. You can see the locators have been created. Now let's have a look at how the script works. Alright, so step 1, import Maya commands as CMDS. We're importing the Maya commands, referring to it as CMDS with this short form here. Okay, so we've got our method, create wheel locators from selection. So step 1, get user selection. So at this point, we should already have the wheels selected in order: front left, front right, rear left, rear right. Okay, so we get the selection. We store it in this variable selection using the list command. So we go cmds.ls list selection equal true, type equal transform. Okay, so then we have stored inside our selection list the names of the 4 tire geos transforms. So we check if the length of the selection is not equal to 4. So it has to be exactly 4. So we're not going to deal with the case of like a motorcycle or a vehicle that has 3 wheels. This one is specifically for 4 wheels. If we have more or less than 4 selected, then we're going to say that's a mistake, and we're going to return this error using cmds.error. Select exactly 4 wheel meshes in order: front left, front right, rear left, rear right. And then we're going to return, which will exit the function, and we won't execute any lines further. So if we have the proper number, if there's 4 selected, then this will not execute, and we'll move on to here. So we've got clean up old groups if they exist. If cmds.objExists, duplicate centered tire geo group. So this is going to check. If we've already run the script before, then this is going to be there already, because later on we make this. And if we are running it for the second time, we just want to do a cleanup. So that's what this is for. So clean up old groups if they exist. So it checks if object exists, duplicate centered tire geo group, and if it exists, then this indented block will run cmds.delete duplicated center tire geo group. So it just gets rid of it if it's already there. If cmds.objExists tire load group, okay, if this one exists, delete it. So that's all that is. So if they're not there, this will not execute, and it will just continue on at the next line. So step 2, duplicate wheels, rename and center pivot. So we make a list called centered wheels, and then we iterate through that list with the variable wheel, taking on each value in the selection list. So we store in dupe the duplicated wheel geo. So what we're doing here is we're duplicating the wheel geometry, and then we're taking the center points of each of those wheel geometries. So instead of altering the pivot points of the geometry that exists in the scene, I'm just going to maintain the state of that geometry. I'm not going to alter it if I don't have to, because what I'm really looking for here is just the position at the center of the geometry of the wheel. I don't really want to permanently change the pivot point necessarily. I want to keep my file intact. So I'm going to just do that. I'm going to duplicate my wheel, and then I'm going to find the center point of the duplicated wheel. So that's what's going in here. So it's iterating through all 4 wheels. It's storing inside this variable dupe the duplicated single wheel. Then I'm using xForm to do center pivot, and then I'm putting centered wheels.append dupe. So I'm putting them all in a list, centered wheels, and that's all the duplicates. Okay, moving on. So we group all the centered wheels, calling it dupe group. Right here, dupe group. cmds.group centered wheels name equal duplicate centered tire geo group. That's that one that we checked for earlier and deleted if we already had it. So here we're going to make it, and now we're going to move on. Create locators and group them. So locator names equal front left tire loc, front right tire loc, rear left tire loc, rear right tire loc. And this ordering here corresponds to the order in which we selected each of the tire geos. That's why you have to select them in order, because if you don't, then you're going to get the naming of these locs different than the positions of the geometry on the car, and then later when we build controls and stuff, it'll all have the wrong names. So that's why we make sure that we select in this order. Okay, so we got our locator names in a list. We have an empty list called locators, and then we're going for name in locator names. So we're iterating through the locator names list, storing each one of these names in the name variable, and then we're doing create a space locator with cmds.spaceLocator command. Okay, we use this indexing at 0 to take the first result of the return of spaceLocator and store it in loc. cmds.xForm, so we're using xForm now, and we're using it to work on the locator and set its translation in world space to 0, 0, 0. So there's this thing about locators to keep in mind. If you make a locator at a specific point in space, then it's going to have a mismatch between where it appears in space and what its position is in the XYZ coordinate system. So what you have to actually do is create the locator, and then after it's created, move it into the proper position. Okay, so we put locators dot append loc. So what we're doing here is we're putting the loc inside the locators list. So these are the names, but then once you create it, you're going to get back a long name, and the long name is going to go in here, and then we're going to put the long names in the list of locators. Alright, so then loc groups is equal to cmds.group locators name equal tire loc group. So we're just making another group here, and we're actually putting all the locators in it. So we're actually feeding in a list to the cmds.group command, and it's going to group everything that's in that list, and it's going to use the long name that are stored in that list. Okay, step 4, match transforms from centered wheels to locators. So for wheel loc in zip, centered wheels locators. So zip is going to combine this pair here, centered wheels and locators, into a tuple pair. Okay, so centered wheels, if we take a look back here, centered wheels is our list of duplicated geos of wheels. Okay, we made it here on line 18, centered wheels. We appended each one of the wheels into it. Okay, so we have two lists here as input arguments to this method zip. So zip is taking in list 1, which is centered wheels, list 2, which is locators, and it's combining them into a new list that is a list of tuple pairs. Okay, but we don't really store that anywhere. We just get that tuple pair right away and unpack it into wheel and loc. Okay, so it's a fancy way of taking two lists and iterating over two lists at the same time and storing it in these two different variables, and that's it. So cmds.delete, we do cmds.parent constraint wheel loc. Okay, so we're doing a parent constraint of the wheel on the locator, and then we're deleting it right away. So this is the method that we're using to actually move the locator into space. So instead of xForming the position of the locator and then moving it directly there, instead we're going to parent constraint with no maintain offset. And you've probably maybe seen this in the viewport. This is a common way to get something to match transforms or to move it. Parent constraint with no maintain offset will move it so that it's aligned in the same place. And then if you delete the parent constraint, well, they'll just be in the same place still without any parent constraint. So this is just matching the transforms from the centered wheels to the locators. That's what's happening there. Okay, so then we're going to return this dictionary, which has keys: centered wheels, locators, centered group, locator group. Okay, so this is just giving back in case we want to use this information later. We'll probably use the locators to build joints and controls out on the joints, but we'll see how that goes. So that's the method, and that's the method that we ran in the viewport, which gave us the result with our 4 locators at the positions of the tires.